Today's May 12, 2022. It is a Thursday, and today I'm going to be importing some data. This data set is basically grades by chemical engineering students at a certain university class, and we have their grades filtered by their assignments. So we have each assignment and the grades that they all got in those assignments. So we have like the midterm and the final, etc. So I'm just going to look for the data set real quick. Which one is it? Maybe the first one. We'll see which one works. Copy path. Okay, so I'm going to just be plotting, just practicing some plotting with the histograms of those assignment grades. So I'm going to do pd.read CSV to read in the data, and I'm going to just paste that path in, import pandas SVD. Pandas is a data analytical library, which you can use to read in data files and also wrangle them and visualize and do exploratory analysis with them, etc. So I'm going to do data.head so you can see the first 5 rows of that data set. So again, these are the assignments. So you have a tutorial, a midterm, a take-home, a final. You have an assignment that was just named assignment and a prefix, and you have the grades of all the students in those assignments. So what I'm going to do is I'm just going to simply do actually I have to import the library. So import Seaborn as SNS. So Seaborn is kind of like a styling library that works in partner with Matplotlib. It's a visualization library. Let me rephrase. And let me put this down. What am I doing? Seaborn as SNS. Did I spell this right? Let me see. Matplotlib.pyplot. Nope, not pyploy. Okay, now we can do SNS hisplot. So hisplot is a histogram in Seaborn, and you know a histogram only takes in one parameter. Well, not the function itself, but like the x value, then the x-axis only takes one variable. So I'm actually going to plot the histogram or the distribution for the midterm grades in this. Did I spell it wrong? Yes. Oh my god. The midterm grades in this engineering class. Okay, so that's that graph, and I'm going to do SNS. Actually, I'll leave it like that. And then I'll do SNS.hisplot, another one, and I'll plot another assignment. I'll do the take home. Alright. Ooh, nice. Okay, but here's the thing. I want these to be 2 separate graphs. So what I'm going to do, and I want them to be in the same kind of like figure. So there's this function called plt.subplots, and it takes in a number of rows you want in your figure. And let's say I want 1 row. And by the way, 1 is default for n rows. And number of columns, so n columns, I want 2 columns. And then I want to set the figure size, so fig size, it starts with the x and then y, so the length and then your width. Your width and then the length. So x is your width, so how large do you want it to be on the x-axis? Well, I'm going to say maybe 15, and then 8 as length. And what it's going to return to you is a figure size, and then with 2 axes. So by axes, they mean graphs. Do I know why they call it axes? No, it doesn't make it's so counterintuitive to what you learned in math class. Like axes are your y and x-axes, not graphs. So it's just weird to me that they call it axes instead of graphs, but to each their own. So what we can do here is we can set those variables the figure equal to fig, and then we can set the axes equal to a certain axis. So I'll do like axis 1 and axis 2, set that equal to that. Now here's the thing. When you have 2 graphs, you want to separate it by a column, and then you want to put them in parentheses. This pair of parentheses, they represent 1 row. So let's say you had 2 columns, then you would do AX2 and AX3. So that means you're going to have 4 graphs in total, so that means you're going to want, to represent each of them in their own respective row. And then note that you also have to put parentheses around those rows just to kind of sum everything up. That's the syntax for it. So let me actually show you what that would look like. Actually, it wouldn't look like anything because I haven't set the graphs equal to anything real quick. So let me just show you that later. But for now, this is what we have. And now you take these two graphs that you have, right? And SNS Seaborn has a parameter called x, which is super really convenient because all you have to do in order for it to show up in your figure. So here is our figure. Here's our two columns and one row, and then our two graphs, our two axes. So in order to make sure that this midterm distribution shows up in the first one, all we have to do is set it equal to whatever first graph we'd set it equal to, which is AX1, and then do the same thing for the second one, AX2, and then when we run it, it should, obviously it's not working. Great, that's amazing. Object has no attribute x-axis. What do you mean? What do you mean? His plot, PLT to subplots and rows and cols, figure. Oh, sorry. One row. There we go. That's what I meant. So now you can see the distribution on the left, which is the midterm distribution, and the distribution on the right, which is a take-home distribution of the grades. Now, to make this a little bit clearer, we're going to do ax1.setTitle. So if you were to plot this in Matplotlib, it would just be plt.title. But because we're working with graphs, individual subplots, you have to do ax1 or whatever graph it is, and then set title method. So I'm going to set this to distribution of midterm grades, and then I'll do the same for the second graph, which is AX2, and I'll do distribution of take-home grades, and then those should appear at the top of each graph, and now you can kind of see how nice that looks. I'm probably going to change this to 20 and then 8, so it's a little bit, I don't like it, hold on, maybe 5. And instead of being so large, maybe 15 now. There we go, that's nicer. So that was just plotting two distributions, which I think is really amazing. Now again, I said I was going to show you what to do if there were two rows. So meaning that you would want like 4 graphs. So in that case, you would want to go in here, you want to do a comma, and then again you want to put a pair of parentheses. Now each pair of parentheses represents a row, so whatever graphs you're going to have in that row, you want to set a variable to that graph. So in this case it would be ax3 and ax4. Alright, and then we're going to wait until this unfreezes. Great. Okay, and then we do absolutely the same thing. So we're going to take this one. Maybe I want to plot, let's say, the final, right? We have a final column and we also have a tutorial column. So maybe I want to plot a tutorial column as well. So I'll do hisplot data tutorial, and then set this equal to axis 4 and set this equal to axis 3, and I run that, and it's going to give me 4 subplots or 4 graphs of each distribution. I could make this a little bit better by setting the height to 5, and then you can see them now. Is there anything else that I want to say? I mean, yeah, you would just do the same thing if you want to give it a title. Okay, and just in case that these axes and figures confuse you, I'm just going to rename the variables so that it makes more sense to you. So it's the same as just saying graph 1, graph 2, graph 3, graph 4, okay? And then you just do, okay, the axis is graph 1, so whatever your graph is, it's going to assign it to the graph 1 in the figure. And then, you know, graph 2, oops, and then graph 3, and then graph 4. and it's going to give you the same result, but I just thought that maybe that would be better for you to understand. But actually it's not going to give you the same result because we forgot to say to change it here in the set title. So we'll do graph 1.setTitle and then graph 2.setTitle, and I might as well just do it for these two. So I'll do distribution of final grades or distribution of tutorial grades, and then run that. Oops, that's actually gonna make sure that you change it to graph 3, graph 4. Run that, and you should get the same result, you know. Probably change the height so that these things don't overlap, maybe to 9. It still overlaps a little bit, so change the height to maybe 11. Run that. Okay, that's nice. So you can clearly see our graphs are histograms for each assignment. So it's basically the distribution of each of the of all the grades in each assignment in that chemical engineering class. So yeah, I think we're good with that, right? If this makes better sense. And then the figure again is the white box. Okay, I think I'm gonna be done with this now. So yeah, bye.